All right, hey guys, we're going to review a topic or concept from Algebra 1 because we need to know about slope and parallel and perpendicular lines and writing equations. And you did all of those things in Algebra 1. But parallel and perpendicular lines are so important or prevalent in geometry that I think it's worth taking a little time to review. So, what is slope and how do you find it? So, one of the things you may remember about slope, you might think, is rise over run. That might come to mind. The variable or the m is what we represent slope with. Have no idea who came up with m. Have no idea, but that's what we use to indicate slope. And so you may remember slope as rise over run. So when we look at an equation, not an equation, when we look at the graph, you can actually identify, if you can identify 2 points, and to find the slope of this line, you can simply draw a right triangle. So I can go up and over. And the slope of that line will be the change in these y values, which is rising, and then from here over to this x value or this point, you are running. And so your rise over run for this graph, you're rising 2 and you're running 1, 2, 3, 4, 5, 6. So the slope of this line is 2 over 6 or 1/3. So this graph, this slope reduces to 1/3. So what that means is that your y values are changing by 1 for every 3 x values that are changing. So up 1 over 3, up 1 over 3. We could do it again, up 1 over 3, and there's a point. So the slope of this line is 1/3. Okay, so what about how do we find the points, or how do we find the slope between 2 points? Well, one thing we could do is we could get a visual, and let's think about where is -1, 4. So -1 up 4 will be somewhere here. And then 2, -3 will be over 2 and down 3. Okay? So here's a line that goes through these 2 points. And so what we want is we want to determine what the slope of that line is. So we could easily do rise over run again. And here I could rise. And when I go from this point up to a point that's across from this point, my y values have changed. My y values are going from -3 to +4. So how much change has there been between this point and this point in terms of y values? Well, there's been a change of started at -3 and we ended at 4, so that is 7. Now, because we are going from here to this point, there's now a change in x's. The change in x's are going from 2 to -1. So 2 to -1 is a change of 3. Now, from this point over, we moved to the left, so we're going to say that negative is -3. So if we do rise over run, for slope, then our rise is 7 and our run is -3. When your line falls, you know that your slope should have a negative value. Okay, so that's -7/3, kind of wrote. But you know, sometimes we need a way to find the slope. Not necessarily doing rise over run, because sometimes plotting those points and things can be kind of time consuming. So here's what I want us to remember. We can also find the slope by finding the change in y's and dividing it by the change in x's. Now, this is a Greek letter, and that Greek letter is delta. And delta in math means change. So the change in y's divided by the change in x's. Well, how do you find the change in y's? Well, in this case, we counted from this point up and from this point up. And so there was a change in your y values of 7. Here our change in y values was 2. But if I just want to work with the 2 points, how do I find the change in y's? Well, I take one y value and I subtract another y value. And I divide it by x sub 2 minus x sub 1. So I have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This is the...
Gabriel Cripps, please come to the front office. Gabriel Cripps, please come to the front office.
Okay. So I have a change in y's, so you're subtracting your y's. You subtract your x's in the same order, and then that will give you your slope. So let's apply that to these 2 points. So if I want to find the slope, one y value is -3, so I will take -3 and subtract the other y value of 4, and I will divide by the change in x's in the same order. I'll take my 2 and I will subtract -1. So now let's look at what we get. I have a -3 minus 4, which is -7. 2 minus a -1 is 2 plus 1, which is 3. So we get the same thing. So this formula is a formula that you learned in Algebra 1, and it's a very useful formula when you want to find the slope between 2 points and you don't want to have to graph it. All right, so how do we find the slope from an equation? Well, one of the things that you learned in Algebra 1 was to take an equation and put the equation in slope-intercept form. Slope-intercept form is y equals mx plus b. Now, to put that in slope-intercept form, that means take this equation and solve this equation for y. That means get y by itself. So this is what I want to get by itself. So I need to take the 3x to the other side. How do I do that? I will subtract 3x from both sides of the equation. They cancel here, and I have 2y equals, putting it in the putting it in the mx plus b form, I'll put -3x first, and then I'll have my plus 8. And then all I have to do is divide every term by 2. To get y by itself, I will divide every term by 2. My 2's cancel. I get y equals -3 over 2x, and the 8 divided by 2, or 8 over 2, actually will give me 4. So what is the slope of the line whose equation was 3x plus 2y equals 8? Our slope will be whatever the coefficient of x is, and the coefficient of x is -3/2. So this is a quick review of how to find the slope in different situations. So now let's review writing equations. So how do you write, or what do you need to write the equation for a line? Well, one of the things that I think you're probably the most familiar with is this form of the equation. That is slope-intercept form. Y equals mx plus b, where m equals the slope and b represents the y-intercept. So if I were going to identify the y-intercept from this graph, this previous graph, the y-intercept is the point where the graph crosses the y-axis. So the y-intercept for this point is actually 2. Okay, so the slope-intercept form, y equals mx plus b, is useful when you have the slope and the y-intercept. We'll abbreviate. Now there's another form of an equation, and that is y minus y sub 1 equals m times x minus x sub 1. And this form is useful when you have the slope, because there's that m, when you have the slope and just a simple point. So m equals the slope, and a point would be x comma y. So there's two different versions. This is the one, the slope-intercept form is the one that you more than likely spent the most time with in Algebra 1. But we're going to actually use this form as well because it is a very useful form also. So here we go. I want us to write the equation of a line that has a slope of 1/3 and a y-intercept of -2. So let's think about what we've been given. So what we have is, we know the slope, m, is 1/3, and I know that the y-intercept is -2. So that makes me think slope-intercept form. So I need to think in terms of y equals mx plus b. So I have a slope of 1/3 and the y-intercept, which we can call b, of -2. So I've got everything I need to write the equation for this line that has the slope of 1/3 and the y-intercept of -2. So my equation will be y equals 1/3 x minus 2. And there's your equation. There's our equation. Oops, ooh, the wind got it. Okay. Well, let's do another one that has a slope and a y-intercept. So I want us to write the equation of the line that has a slope of -3 and a y-intercept of -6. So our slope, -3, and our y-intercept, -6. All right, so slope and y-intercept makes me think of y equals mx plus b. So all I have to do now is substitute -3 for m and -6 for b. And I'll have my equation. Y equals -3 times x minus 6. And there's your equation that has a slope of -3 and a y-intercept of 6. Okay, so now I want us to take a look at how do we write the equation of a line when we don't have the y-intercept. When we don't have the y-intercept and we have a point, then we're going to start this process a little differently. I want us to write the equation of a line that has a slope of -2 and the line passes through the point 3, -5. Now I want to just get a little visual of what this what this line looks like. I have a point at 3, -5. I'll go over 3, down 5. I have a slope of -2, which means the line is going to fall. So my line is going to look something like this. And this is just a basic graph of what I think it looks like. So notice that we do not have the y-intercept, but that's okay, we don't need it. As long as we have a point and the slope, we can write the equation. We can write the equation in point slope form, which is y minus y sub 1 equals m times x minus x sub 1. All right, so what is this going to look like? We're going to get y1 from our point of -5, and we're going to get our x sub 1 point from our point, and it's 3. So this is what it looks like. Y minus -5, you got to be careful with signs, equals a slope of -2 times x minus 3. So cleaning this equation up a little bit, we're going to get a y plus 5 equals 2 times x, nope, that's negative 2 times x minus 3. And here's the equation that has a slope of negative 2 and passes through the point negative or positive 3, negative 5. Okay? All right, let's do one more. Now, in this next example, we have write the equation of the line that has a slope of 1/2 and passes through the point 2, negative 5. Okay, so we have the slope and we have a point. So I'm going to start with y minus y sub 1, which is negative 5, equals m, which is the slope of 1/2, times x minus 2. When I clean this up, I get y plus 5 equals 1/2 times x minus 2. Now, both of these equations here, these two equations, I left in slope-intercept form. No, that's point-slope form, sorry. Both of these equations I've left in point-slope form because you've used a point and the slope to write the equation. But each of these could be written from this version and this version. We could write these in slope-intercept form if you want to. So slope-intercept form, remember, is y equals mx plus b. So I'm going to do this. I'm going to distribute the negative 2. So I have y plus 5 equals negative 2x plus 6. The negative 2 times the negative 3 is positive 6. And now all I have to do to get y by itself is subtract 5. And I end up with y equals, this is squished in here, I'm sorry, negative 2x plus 1. Positive 6 minus 5 gives me positive 1. And so this equation is in slope-intercept form. So let's do that with this equation here. So the first thing I'll do is to get rid of the parentheses by multiplying. So I have y plus 5 equals, when I multiply 1/2 by x, I get 1/2 x. When I multiply 1/2 by negative 2, I ultimately get negative 1. So now all I have to do to put this equation in slope-intercept form, I will subtract 5 from both sides, and I'm left with y equals 1/2 x minus 6. And so here is this equation in slope-intercept form. So these two equations look different, but they represent the same line, as do these two equations, well, right here, as do this equation and this equation. They look very different, but they represent the same line. So that's a small, very quick review of writing equations of lines and finding slope that we're going to need to be able to do our next lesson, which is lesson 3, where we're going to be working with parallel and perpendicular lines.